of them, unfortunately, which is where I said responsibly AI has 12 different principles and we can go on with that. So even bias, right? I think organizations need to understand what bias is and how biases can come in. I'll use two examples, but before that, let me tell you, biases, it could be gender, it could be race, it could be ethnicity, it could be age, it could be socio-economical impact, it could be regional disability, and so on and so forth, right? Minority, even age, everything can be biased, right? So an example could be if you Google, forget about Google, using AI, show me some pictures of CEOs, it will only show you elderly people, right? That itself is a bias, right? Show me some pictures of nurses, it will only show you women. It's biased on men, right? So, but if you show in engineering, it will show only men. So bias is already built into the ecosystem, right? Humans itself are biased towards so many things, right? So the way I want to explain bias is there are different types of biases. It's not just gender, race, ethnicity, and so on. There are different types of biases which I will probably call out exclusively. One is exclusion bias, meaning to say you have excluded a segment. Like I was talking to you about voice, right? I mean, if you're only considering Caucasian accents, you would have excluded majority of the other accents. So majority of the other accents will fail, right? Next is confirmation bias. If you go on confirming a wrong result, right, saying that it's correct, it becomes a confirmation bias that you've already embedded into the system. Okay. Third is training data. I mean, of course, all of you know enough about training data bias. If there's a bias within the training data, there's indirect biases also. One common example that I quote in training data bias is now Google's example, Amazon's example of recruitment. Okay, they use 12 years of or 10 years of data to train their AI model. But what happened is start building a gender bias towards men. And the only reason it built that gender bias towards men was because in the last 10 years, more men had joined the company than women. So it started building a bias. So similarly, there are some indirect biases. If you train your recruitment engine to say that there should not be any gaps of more than 3 months in somebody's career, a lot of women, mid-aged women will start getting rejected, primarily because they would have gone on a maternity leave and it would have got extended. So these are indirect biases. Though you would have taken out gender, though you would have taken out name and so on and so forth, it starts building those biases. So the next one is measurement bias. How are you actually measuring your AI model's results, right? They could build a bias over that. Then of course the next one would be algorithmic bias, where people very much understand what algorithmic bias is. I don't want to explain that. Historical bias is something that has happened in the past. Like I was telling you, right? CEOs, why only old people? Today there's so many, or elderly people, not old people. There are so many younger people, all right, in historical bias. Then you have sampling bias. So which I went back into the recruitment, the accent perspective. Though representability and sampling, there's a representability bias, meaning to say that have you considered certain segments, all right, in your model data set, right? That's representability. And going into sampling, what kind of representability have you used? You might have used 100,000 records of a Caucasian voice, whereas 10 records of an Indian voice, and said, okay, I've taken into consideration representability, but sampling is flawed. So sampling bias comes into significant play there. Then you have cognitive bias, which is the most challenging bias across all biases, meaning to say that what are we thinking? The person who's developing the algorithm, what is he or she thinking? That is cognitive bias. So when actually you are developing the algorithm, and if you have a bias in your mindset, how do you attend to that? I mean, you are actually going to embed the algorithm with that particular bias. So how do you come out of that? So one of the mitigation is have diverse teams, right? So that there are different people looking at it from a different perspective, come into attend to cognitive bias. Then you have content bias. Let's say you're in a media house, and the media house is very right-winged or left-wing. Your entire AI model will be left-wing or right-wing because of content bias. So these are different types of biases that are actually there, and people only talk about gender bias, right? So I think it's very, very important for people to understand the different types of biases that are existing in the AI systems, so that people consider all these aspects when they are building AI systems, and also deploy AI systems in a more ethical manner and a responsible manner. Now coming to a few, I think I've already quoted examples on recruitment. Banking industry is another, or insurance industry is a classic example on how biases can be built in, right? Based on socioeconomic, even they go to the extent of saying if you are living in a particular PIN code, you can get rejected for a loan, or your interest rates can become much higher, only because the PIN code is very well known for crime rates. All right. Similarly, if you are of a particular segment, if you are of a different surname, defaulters are more. I mean, these are the AI engines that can be built because, and these are not being built because of your name, because of the trend that is there in your behind the data set that it is being fed. So the more and more importance for you to use privacy enhancing technologies, also called PETs, to ensure that you anonymize and pseudonymize such data before it is trained with that data. So data cleansing comes into picture, right? PETs like differential privacy, where you actually remove all the identifiers and then train the data set. But whereas that will actually limit your usage of the data set. So federated learning is typically used in healthcare, right? Where it was used in during COVID times, where hospitals had to share data of what kind of cases are coming into picture and what medication is being effective and so on and so forth. So in that scenario, federated learning was used to go to each hospital. The algorithm actually goes to each hospital, learns from that particular data set and comes back. So, but then even when you use certain PETs, you can still build in bias. Now, for example, on the healthcare perspective, if your data set is primarily from a particular segment of a socio-economical, or let's say white people, all right, your entire data set is on white people, the black people will not actually abide to the kind of abnormalities or anomalies of the white segment, right? Similarly, in India, I mean, south versus north versus rural versus urban, right? Most of the data sets that are there would be urban. Rural people hardly go to the hospital, right? So your data set itself is flawed. Whereas you may think you have a lot of data sets, the representability comes into picture. So I mean, I can go on and on. I don't want to take up too much time. So that is on bias. So now I just want to touch upon very briefly how to mitigate the biases. Sorry, I always make notes because I don't want to lose out on any aspects. All right. So typical impact of biases, I'm sure all of you agree, is social inequality, stereotypes. All right, stereotypes being built in, legal, ethical and legal concerns, and flawed decisions and so on. So how do you mitigate biases? Firstly, clean data, training data. Right? I think you should emphasize on clean data, training data. How do you do that? Go with whitelisted data sets. Right? Don't go with the open data sets. And if you even go with open data sets, ensure you sanitize that data when you get it. Right? So that or at least understand the data that you get, so that if you encounter such biases, you'll be able to mitigate it accordingly. Right. Third is output screeners, it's called. So keep monitoring your outputs, right? Because it's important to understand how the data that you are fed in and the algorithm work together to deliver the desired output. Okay. Then you audit at particular periods of time. Monitoring is a very clear emphasis, because again, privacy laws and AI laws and guidances speak a lot about monitoring. Once you roll out an AI engine, you should always monitor the AI engine at periodic intervals. Okay, then you have diverse teams, you have better sampling, have a very robust governance mechanism. Again, that's a separate topic by itself. And validate using responsible AI. Right? I can go on, but I'll stop here. Thanks.